In today's lesson, we'll be learning how to connect English with mathematics and graphing lines. In our first example, we have a word problem. I've gone ahead and broken it up into 4 individual sentences. Ian owns a small airplane. He pays $50 per hour for flying time and $300 per month for hangar fees at the local airport. If Ian rented the same type of airplane at the local flying club, it would cost him $100 per hour. How many hours will Ian have to fly each month so that the cost of renting will be the same as the cost of flying his own plane? The first sentence is just a description of the overall situation. The second sentence describes the fee structure at the local airport. $50 per hour is a rate, and a rate is multiplication. So this is going to be multiply by 50. $300 per month is also a rate, but I'm going to talk about that a little bit later. The third sentence describes this fee structure at the local flying club. $100 per hour is a rate, and a rate involves multiplication. So this is the same thing as multiply by 100. In our last sentence, we have 2 variables. We have hours and we have cost. Cost is the dependent variable. I'm going to give it a letter of C because it depends on the number of hours. And hours is the independent variable, and I'm going to give that a variable of T, which is going to stand for time. Another key piece of information here, and that is each month. So we're only looking at a 1-month period of time. So the rate of $300 per month doesn't really matter. It just becomes a flat fee. Next, we're going to have to write let statements to represent the variables in this situation. Remember, hours is the independent variable and cost is the dependent variable. We already decided that cost would be represented by the variable of C. So I'm going to write let C represent the total cost in dollars. I already decided that hours would be represented by the variable of T. I'm going to write let T represent the time in hours. The local airport charges $50 per hour as well as $300 per month. Since we're dealing with a time period of 1 month, the $300 per month rate just becomes a constant. So I can represent the fee structure at the local airport with this equation. The cost is 50T plus 300 because the $300 is the flat monthly fee as well as the $50 per hour rate. Meanwhile, the local flying club charges $100 per hour. It doesn't have a monthly fee. So we can represent the fee structure at the local flying club with this equation. The cost is equal to 100T. So to recap, the local airport charges a $300 monthly flat fee, as well as $50 per hour, while the local flying club charges only $100 per hour, and it doesn't have a monthly fee attached. If you were to graph C equals 50T plus 300, the slope would be 50, while the y-intercept would be positive 300. Let's just make a brief note of that. So the slope would be equal to 50, and the y-intercept would be equal to positive 300. Meanwhile, if you were to graph C equals 100t, the slope would be 100, and the y-intercept, since there is no value here, would be 0. So let's make a brief note of that. So the slope here would be 100, and the y-intercept would just be 0. I've gone ahead and graphed my two equations. The red line is c is equal to 50t plus 300. Meanwhile, the blue line is c is equal to 100t. If you remember, the blue line has a y-intercept of 0, and the red line has a y-intercept of positive 300. We want to find the point of intersection of these two lines. If you take a close look, it is right over here, and that coordinate is 600, which means at 6 hours, it will cost $600 at both the local airport and the flying club. What exactly does this point of intersection mean? Well, if you're flying for less than 6 hours, it will be cheaper to do that at the local flying club. However, if you're flying for more than 6 hours, it will be cheaper at the airport. Finally, we want to see if our point of intersection is correct. So I'm going to rewrite both my equations. C is equal to 100t, and c is equal to 50t plus 300. What I'm going to do here is I'm going to substitute in the point of intersection, and I'm going to see if left side is equal to right side. And if they are, that means this coordinate lies on that line. Over on the left, I'm going to replace the variable of c with 600 in brackets. And I'm going to replace the variable of t with 6 in brackets. So 600 stays the same, and 100 times 6 is 600. Therefore, left side is equal to right side. I'm going to do the exact same thing on the right side. I'm going to substitute in this coordinate. If left side is equal to right side, that means this coordinate lies on that line. So I'm going to replace the variable of c with 600 in brackets. I'm going to replace the variable of t with 6 in brackets, and the plus 300 stays the same. So the 600 here stays exactly the same. 50 times 6 is 300. The plus 300 stays the same. So 300 plus 300, pretty simple, that is 600. So as you can see, the left side is equal to the right side. A little bit of a concluding sentence here. Since left side equals right side for both equations, therefore 600 is the point of intersection. Let's also write a concluding sentence for the entire problem. Therefore, the cost will be the same if Ian flies for 6 hours. And we already know that the cost will be $600.